A data protection impact assessment, DPIA, is often described as a form or a report, but the real purpose is more demanding than paperwork. A DPIA is a disciplined way to decide whether a particular data processing activity should happen as designed, what risks it creates for people, and what changes are required before it can move forward responsibly. When a DPIA becomes a box-checking exercise, it tends to produce long descriptions and vague statements like risk is mitigated, yet nothing changes in the system and nobody can explain what trade-offs were accepted. A decision-ready DPIA is different because it is written to support a real decision, with clear risk reasoning, clear controls, and clear outcomes that a leader can approve or send back for redesign. For beginners, the most helpful mindset is to treat a DPIA as a privacy engineering document, even if it is written in plain language, because it connects purpose, data flow, and controls in a way that should guide product behavior. It also serves as a record of why decisions were made, which matters later when features evolve, vendors change, or incidents happen. The goal in this episode is to make DPIA work feel practical by showing how to keep the analysis sharp, how to avoid the most common weak spots, and how to produce results that lead to action rather than shelfware. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. A sharp DPIA starts with a clear and complete description of the processing, but complete does not mean bloated. You need to describe what the system does in a way that a reviewer can understand without being on the team, including what data is collected, where it comes from, where it goes, and what decisions or outputs it supports. This description must include purpose, because purpose is the North Star that defines what is necessary and what is excess. Beginners often write a generic purpose like improve user experience, which sounds good but provides no boundary, so it allows almost any data use to look justified. A stronger purpose statement ties to a specific user need or organizational need, such as preventing account takeover, delivering a service reliably, or meeting a clear legal obligation, and it explains why the processing is needed to meet that goal. The description should also identify actors, such as internal teams and service providers, because sharing changes risk even if the core processing is the same. Another common beginner mistake is describing the feature as the user sees it while skipping the backend behavior, like logs, analytics, or data warehouse flows, which is where many privacy issues hide. When the processing description is tight and factual, the rest of the DPIA can build on it without guessing. Data mapping is the backbone of decision-ready analysis, because privacy risk is largely about where data travels and what it becomes along the way. A DPIA should capture key data elements, the points where they are collected, the transformations they undergo, and the destinations that store or consume them. The map does not need to be a diagram to be effective. It can be explained clearly in narrative form, as long as the flow from source to sink is understandable and complete. Beginners often list categories like contact information and usage data without specifying what is inside those categories, which weakens analysis because you cannot assess sensitivity and necessity without more detail. You should know whether usage data includes device identifiers, whether logs include full URLs, whether support tickets include attachments, and whether location signals are precise or approximate. Another important mapping element is derived data, such as risk scores, segments, or inferences produced by machine learning, because derived data can be more sensitive than raw inputs and can create new harms. Mapping should also include retention points, because risk accumulates when copies and backups persist beyond the intended period. When the data flow is concrete, you can identify where controls must apply and where risk is highest. After mapping, the DPIA needs necessity and proportionality reasoning that goes beyond simple statements like the data is needed. Necessity means the processing is required to achieve the stated purpose, and proportionality means the processing is not excessive compared to the benefit and the context. Beginners often confuse these ideas with convenience, using language like it helps us understand users, which can justify endless collection. A decision-ready DPIA asks what minimum data and minimum collection frequency can achieve the goal, and whether there are alternatives that reduce risk, such as using aggregated metrics, on-device processing, shorter retention, or opt-in design. It also asks whether the same purpose can be met with less intrusive methods, such as verifying a transaction without building a long behavioral profile. Proportionality includes considering user expectations and power dynamics, such as whether the processing happens in a workplace or involves children, where the tolerance for invasive collection should be lower. Another proportionality question is whether the processing can be limited to a subset of users who truly need it, rather than turning it on for everyone by default. The output of this step should be an explicit statement of what is necessary, what is optional, and what is ruled out because it is disproportionate. Risk identification in a DPIA is where many documents become vague, so sharpness requires specificity about harms and pathways. A useful approach is to name the people affected, name the potential harms, and name how those harms could occur. Harms can include loss of confidentiality through breach, misuse of data for unexpected purposes, discrimination or unfair treatment through profiling, chilling effects when people avoid services due to surveillance, and loss of control when deletion or access rights cannot be exercised. Pathways can include excessive sharing with vendors, overbroad access internally, uncontrolled retention, weak transparency leading to surprise, or model inference that reveals sensitive traits. Beginners sometimes list generic risks like data could be leaked, which is true of almost any system and therefore not decision-ready. A sharper analysis ties risks to particular elements in the data flow, such as location trails retained for months, or chat transcripts stored in vendor systems, or biometric templates centralized in a database. It also distinguishes between likelihood and impact in a grounded way, acknowledging uncertainty while still making a clear judgment. When risk statements are concrete, leaders can understand what they are accepting and teams can see what needs to change. Controls and mitigations should then be matched to the risks in a way that is measurable and testable, because mitigation language is where many DPIAs become wishful. A mitigation like "we will secure the data" is not actionable, but a mitigation like "restrict access to defined roles, log access, and review logs regularly" is something you can implement and verify. Controls might include data minimization, purpose limitation, consent or opt-in for non-essential uses, retention limits with deletion enforcement, vendor restrictions on secondary use, encryption, strong authentication, and monitoring for privacy regressions. The key is to connect each control to a risk pathway, so the reader sees how it reduces likelihood or impact. Beginners often list a standard set of security controls without addressing privacy-specific issues like function creep or transparency, so the analysis feels incomplete. Another common weakness is failing to address operational reality, such as claiming deletion is possible without confirming that it works across backups and vendor systems. Decision-ready mitigation includes ownership and timing, because a control that will be added later without a plan is not a control. When mitigations are clear, you can translate them into requirements for release and into tasks for remediation tracking. Residual risk is the part of the DPIA where decisions become real, because even with controls, some risk remains. A sharp DPIA does not pretend residual risk is zero, and it does not hide behind vague words like acceptable without explanation. Instead, it explains what risk remains, why it cannot be fully eliminated, and why the remaining risk is considered tolerable given the benefits and safeguards. For example, a fraud detection system may still need to analyze certain behavioral signals, and some profiling risk may remain, but retention and access controls might reduce the exposure. A location-based feature may still require approximate location, and some sensitivity remains, but the system might avoid precise tracking and store only short-lived data. Beginners sometimes fear that acknowledging residual risk is a failure, but acknowledging it is a sign of maturity because it allows leaders to make informed choices. A decision-ready DPIA also identifies what conditions would change the risk judgment, such as expanding the feature to new regions, adding new vendors, or introducing a new use of the data. This creates a link to change management because it tells the organization when the DPIA must be revisited. Residual risk is where accountability lives, because it documents what the organization decided to accept and why. Stakeholder input is another ingredient that separates sharp DPIAs from shallow ones, because privacy risk often spans technical, legal, and user experience concerns. Engineering can explain data flows and feasibility of controls. Security can assess threat paths and detection. Product can clarify purpose and user benefits. Legal can clarify obligations, and user experience can ensure transparency and choice are meaningful. A beginner mistake is treating the DPIA as a privacy team's solo exercise, which leads to inaccurate descriptions and unrealistic mitigations. Another mistake is collecting stakeholder input but failing to integrate it into the analysis, so the document becomes a transcript of opinions rather than a coherent risk decision. Sharp analysis means using input to refine facts, test assumptions, and identify controls that will actually work in production. It also means documenting disagreements and resolutions, because sometimes teams have different views on necessity or risk tolerance. When stakeholder involvement is structured, it increases buy-in for remediation because teams feel the DPIA reflects reality and shared ownership. Decision-ready DPIAs are not about winning arguments. They are about reaching defensible decisions with clear responsibilities. Timing and integration into development workflows matter because a DPIA that arrives after a feature is already built becomes a conflict instead of a guide. If the DPIA identifies that a feature should use less data or should offer opt-in, those design choices are easier and cheaper to implement early. When the DPIA happens late, teams may resist changes because timelines are tight, and privacy becomes seen as a blocker rather than a partner. A decision-ready DPIA is therefore designed to fit into product life cycles, with early scoping, midstream refinement as designs solidify, and a final check before launch to confirm controls are implemented. Beginners sometimes think of a DPIA as a single document created at one point in time, but in practice it can evolve as the feature evolves, especially for high-risk processing. Integration also includes linking the DPIA outputs to concrete tasks, such as adding retention controls, updating vendor agreements, or adjusting consent design. The DPIA should not end at approval. It should feed into verification steps that confirm the system matches the approved design. When timing is aligned with development, the DPIA becomes a tool for building safer systems rather than a retroactive critique. A strong DPIA also pays attention to transparency and user control because those are central to whether processing feels fair and trustworthy. Transparency is not only a legal requirement in many contexts, it is also a risk control because surprise is a major driver of complaints and reputational harm. If the processing involves tracking, profiling, or sharing with third parties, the DPIA should consider how that will be communicated to users and what choices they will have. Choices should be meaningful, which means users can decline non-essential processing without losing the core service or being manipulated into agreeing. For some processing, like security logging, opt-out may not be feasible, but transparency about purpose, retention, and access can still reduce distrust. Beginners sometimes treat transparency as a final step, but it should be analyzed early because it influences design decisions like what settings exist and how consent is recorded. The DPIA should also consider how users can exercise rights like access or deletion, especially when data is distributed across vendors and derived datasets. If the system cannot support those controls reliably, that is a risk and a design issue, not just an operational inconvenience. Decision-ready analysis connects user experience, rights handling, and back-end data flows into one coherent view. Verification and monitoring complete the story because a DPIA is only as true as the system that ships. A common failure is approving a design with strong controls and then discovering later that implementation drifted, such as tracking events including extra fields, retention settings never applied, or vendors sharing broader than described. Decision-ready DPIAs therefore include plans for verification, like checking event schemas, testing deletion flows, confirming access controls, and reviewing whether consent choices affect data routing as intended. Monitoring can include ongoing checks for privacy regressions, such as detection of sensitive fields appearing in telemetry or new third-party endpoints appearing in app traffic. Beginners sometimes assume that once the DPIA is approved, the job is done, but privacy risk changes over time through updates and integrations. The DPIA should define what changes trigger a revisit, such as adding a new data category, expanding to new user groups, or introducing automated decisions. It should also connect to incident response, because if an incident involves the processing covered by the DPIA, the document should help the organization understand what was expected and what went wrong. When verification and monitoring are built in, the DPIA becomes part of a living control system. Completing DPIAs with sharp, decision-ready analysis means treating the document as a tool for accountable choices rather than a compliance artifact. You begin with a clear, accurate description of processing and a concrete data flow narrative so risks and controls can be tied to reality. You perform necessity and proportionality reasoning that sets boundaries, identifies alternatives, and prevents convenience from masquerading as necessity. You identify risks in specific harm pathways and match mitigations to those pathways with controls that are measurable and implementable. You acknowledge residual risk honestly and document the reasons and conditions for acceptance, creating a trail of accountable decisions. You involve stakeholders to improve accuracy and feasibility, and you integrate the DPIA into development timing so it guides design rather than fights finished work. You consider transparency, user control, and rights handling as core design elements, not afterthoughts. You end with verification and monitoring plans so the approved design stays true over time. When a DPIA is built this way, it becomes a practical bridge between privacy principles and real systems, helping teams ship useful features while respecting the people whose data makes those features possible.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.